Hi. So today's
Hello, yeah, good
yeah.
evening.
Good evening. Uh,
Sir, your voice is not coming. It's a very, very low.
right now is it fine? Is that okay? This fine?
No, it's still not okay. So it's a very, very on the low tone.
Okay. My settings here are they're like on full volume actually. So if you can use your earphones, might be good. If you can use the earphones to listen. Is that okay now?
Yeah,
Yes,
it's
sir.
yes, sir, it's okay.
Okay, fine. Okay. So I think today we are having this revision session, and we will be doing the revision sessions this way. We'll do week 11 and 12 first, and then maybe later on, I think on Saturday we'll be doing 9 and 10. So today's session I'll be covering week 11, 12, and related questions, right? So if you have any previous year questions ready with you, you can uh, tell me. We can solve those questions as well. If you have any doubts in those questions, that is also fine. So before starting doing the questions, I'll do one thing. I'll just put out the important topics which are there, which we should focus on while going for this exam. So I'll just write down some of the topics, and maybe we can discuss over that. Okay. Yes. So yeah, I'll solve this week 12 question. So we will start with the end part of the week 11 first, which is transformations of two random variables, and then we'll see what is bivariate, what is bivariate normal, and uh, you know multivariate normal, and what are its properties. So what I'll do is I will just so KKT, I think it will be covered on the Saturday. So today I think we'll be doing week 11 and 12, and its related questions. All right. Okay. So what I'll do is I will just write down all the important things, and then we can discuss that all along, right? Yeah. Yes. So I will just so what we'll do is we'll deal with only important topics. I will not go into like much of the theory, so that we can actually give some time for solving questions. Is that fine? My screen visible to all of you?
Yes, sir.
Yeah.
Yes, sir.
So if you have any other doubts, right? If you have any previous year questions also, you can let me know. We can solve some of the questions from uh, mock also. So related to week 11 and 12, and then maybe we can finish off this week 11 12. So the most important topic, I think what we have learned new in this, I think apart from the joint density, the marginal density, how to find out the probability given the events, I'm assuming that all of that you're comfortable with. And so we'll move to this topic, which is called as okay. I think okay. I'll just give me a minute. Maybe I this doesn't look good, right? So I'll just you open this PDF into different. Uh, During now. Hope this is visible. Okay. So this is first revision session. Session 1 is on week 11 and 12. Fine. Now, what is the first topic we'll be discussing today is transformations of two random variables. Okay, so what we have known previously is that if I know the joint density of two random variables, and if these two random variables are the functions of another two random variables, in that case we will be able to find out the joint density of the uh, two new random variables, right? On the basis of what I have known earlier. So for example, or how does that, let's say x and y are the random variables for which I know the joint density of these two random variables. Fine, so this is known to me. This is the joint density is known to me. Then if I know, let's say x is a some function, right? So let's say some function, this r denotes the function. Okay, like let's say it's kind of saying that it is f of r comma w, sorry, f of w comma z, let's say f of w comma z. So that means what? X is a function of two random variable, right? So instead of writing f here, I'm writing or I'm denoting it by r. So it's some function of, let's say, w and z. Similarly, y is a function of some other function of w and z, right? This joint density I know, so I know the joint density of x and y. Let's say x is a function of two other random variables, w and z. What I don't know is I don't know the joint density of w and z. So let's say the joint density of w and z is denoted by g. So g w z of w comma z, it is unknown to me, right? It is unknown to me. So how to find out this joint density by using this information? So what, how the way to find it out is this one: g of wz of w comma z is equal to, so what is known to me, f of xy. So f of xy, I will put instead of x as this function. So here it will be r of w comma z, and here it will be s of w comma z, right? And we'll multiply with the mod of determinant of its Jacobian. Okay, so I should write mod of determinant of a Jacobian like this. Right? So this is the way of finding out joint density of two unknown random variables. What is this Jacobian is? Jacobian is basically, it's a partial derivative of r with respect to w, partial derivative of this function with respect to z, and here it will be partial derivative of s with respect to w. There it is partial derivative to z. So this is my determinant of G. Fine. So you can argue that, let's say you can say that it is del x by del w and del x by del z, or del y by del w and del y by del z. That also is fine. Fine. And we'll have to take the modulus of this determinant of J. Fine.
So can you
Yeah.
sir, write in that way also what we are told, because that is more convenient to remember.
Yeah, that is just fine. So you can write this, it's del x by del w, del x by, but you remember that x, if I'm using here, right, that has to be this function, right? And del z, del x, del y by del w, del y by del z. So that is also fine. Okay. Del z. Okay. So maybe I'll take one example here to solve, like let's solve one example here on this topic to better understand what I've said. Let's say you have, let's say this is a question, and I'm saying that, let's say you have the joint density of uh, x as,
Sir, we will get this PDF once the session is completed. What you are writing, sir?
yeah, if you want I can just share that in the calendar so you can
Yeah,
download it
please,
from
please,
there.
please share it, sir.
Okay, fine. So okay, then I'll write it properly here. So let us say, let us say, okay, just give me a minute. I have, just give me a minute. Okay, so the question is, let's say if x and y are the two random variables, and they are, let's say these are the IID random variables with uh, exponential IID random variables with lambda equals to, let's say, 2. Fine. And x is a function of w and z, the two different random variables, such that, or let's say, I will not directly write that. I'll say that w is another random variable which is a function of x and y. So it is, let's say, x plus y, and z is another random variable with, uh, you know, maybe I'll do one thing. I'll just take this lambda as, say, 3 to to avoid the confusion between z and 2, right? So z is a random variable which is x minus y. So the question is, find the joint density of wz given this information. Okay, so let's say if this is the information, so how to approach this problem, right? So how to approach this problem, do I know the joint density of x and y? As I have mentioned it previously, we should know one of the joint densities, right? So do I know the joint density of x and y here? Yes or no? Yes, right? How to, okay, how to find out?
Yes.
So these are the
What is
IID
it?
random variables, right? So that means they are independent and identically distributed. So that means, what is the PDF of x, or the marginal density of x is, it is lambda. So lambda is 3
Lambda
here, e to the
3
power
power minus 3 minus
3x,
3x.
right? And what is the what is the marginal density of y? It is lambda again, e to the power minus 3x. And since they are independent, right, because it is given to me that they are independent and identically distributed, what will be their joint density will look like? So fxy of x comma y will be what? So if they are independent, then it will be like this: fx of the, it is a product of marginal density if x and y are independent.
Sir, in marginal density of F5, you have written e raised to power minus 3. It should be y. You have
Yeah,
written
yeah,
x.
yeah, yeah, correct, correct. Yes, it should be y here. Yeah. Okay. So if I use this logic, then the joint density of xy will be what? It will be the multiplication of these two quantities, this one and this one. So what that will be? 3 into 3 will become equal to 9, and e to the power minus 3x into e to the power minus 3y. So by combining these two quantities, it will be 9 e to the power minus 3 common, and it is x plus y. Is that fine? I hope that is okay.
Fine, sir, fine.
Right. So this this it this is my joint density of xy. So now I know the joint density of xy. What is the next thing I need to do? I need to find out x in terms of w and z, and y in terms of w and z. Right. Currently, I have these equations. Let's say this is equation number one, and this is equation number two. Let us try to, uh, so currently the w is in terms of x and y, and z also is in terms of x and y, but I need x in terms of w and z, and y in terms of w and z. So how to tackle that, right? So currently I have this w equal to x plus y, and z equals to x minus y. That's this is equation 1 and this is equation 2. Suppose if I add these two equations, what it will happen? So one equation 1 plus equation 2. If I add these two, what will happen? It will be it will look like this: w equal to x plus y plus z equals to x minus y. So the uh, it will become w plus z equals to 2x, which gives me x as equal to w plus z by 2. Fine. Let's say this is equation number 3. And if I subtract equation 2 from equation 1, what will happen, right? So w equal to x plus y minus z equals to x minus y. So if do it minus here, what will happen to this? So the signs of this will change. This will become minus, this will become minus, this will become plus. Then what I'll get here is w minus z equal to x and x will get cancelled. It will become 2y. And from there I'll get y equal to w minus z by 2. This is equation number 4. So now, if I look at this equation, I have got joint density, I have got this, I have got this. I need to find out the determinant of this Jacobian, right? And you can actually find it out using this formula or this formula. Both of them are same. So let's try to find it out, right? Okay. By looking at it, so the Jacobian will be what? So Jacobian will be uh, del x by del w, del x by del z, del y by del w, and del y by del z. So that should be equal to del x by del w. What is it? If I look at equation number 3, so it will be
Half.
half. Del x by del z is again that will be half, right? So you can write like separately also. It's like x can be written as w by 2 plus z by 2. So you can think about that. Here also y can be written as w by 2 minus z by 2. And if I differentiate this with respect to w, it will become half. With respect to z, it will become half. And what about this? Here also it is half, and this is minus half, right? Uh, so if I just find out its determinant, it will be minus 1 by 4, minus 1 by 4. So that is minus 2 by 4, which I can say that minus 1 by 2. So it is determinant of Jacobian. So, but we don't need determinant of Jacobian only. We need the modulus of determinant of Jacobian. So that is mod of minus half, that is become plus half. Now I substitute everything into this function, not or this equation rather, to get the joint density of W and Z. So the the joint density of W and Z will be, it will become fxy of x is what now? X is W plus Z by 2. So that will be W plus Z by 2. Y is W minus Z by 2. W minus Z by 2 into determinant of Jacobian. So modulus that is equal to half. But what is fxy here? It is 9 e to the power minus 3 x plus y. So I'll substitute the values of x and y here to get the joint density. So let us say if I substitute it, it will become e to the power minus what is it? Uh,
W.
1 by 3, right? It is 9 e to the power minus 3. 9 uh, minus 3, and x is w plus z by 2 plus yeah,
We
plus
already have x plus y, na? Is W.
w minus z by 2. This is x plus y, right? This is x, this is y. So what is x plus y? The z will cancel, and this will become, yeah, so it will be 9 e to the power minus w, 9 e to the power minus 3
3W.
3W. So that is what. So the joint density of W and Z, it is a function of what? It's a function of only Z, right? Only W, right? It is free from Z anyway.
It will be 9 by 2, right?
Why 9 by 2? Yeah. Sorry.
Into half to Z,
Yeah,
right?
I forgot here. Yes. So it should be 9 by 2, right? So that half I forgot. So basically, it is 9 by 2 e to the power minus 3W. That is my the joint density of this, right? So one more part is that we need to find out its support. Uh, if you can find it out, I think shall I show you to you, or will you do that? So the what is the support of x here, x and y here? So basically, x when it is exponential, so then x will take values,
Greater than equal to 0.
and y is
0 to infinity.
Greater than equal
greater
to
than equal to 0, right? So that is clear. So what? So if I wanted to plot the support for x and y, how does that will look like? So x and y, that will be the entire portion, right?
Sir,
The first quadrant. Yeah.
exponential is defined only for greater than 0.
Yes. Exponential is always greater than 0. The random variable will take values greater than 0.
So then, which distribution can take negative?
Sorry.
Like, which distribution can take
Can
negative?
can what?
Negative random variables.
Which one? Which random variables? The w and z or the x and y?
Anything.
X is a exponentially distributed, right? X was exponentially distributed, was given to me. Y is also exponentially distributed. That's why I know what are the values taken by it, right? So this is going to be
Yeah,
your
I'm asking like in general.
in general. What are the distributions that will be there in the quiz? Is that you are asking?
I'm asking which distribution can take negative values.
Oh, still, I don't understand what is your exact question.
Oh, okay.
Okay, you can type if you want. I maybe I'm not able to.
Yeah, okay.
Okay, and you let me know once you typed it, because I may not be able to see the chat, so you can just let me know once it is done. Okay, is that okay? So how will you find out it for w and that? So you have these two equations, right? X is given as w plus z by 2. So if x is taking the values greater than equal to 0, so first of all you see that for x equal to 0, what are the values of w, and so w equals to minus z, and when y is equal to 0, w equals to plus z, right? So from there actually you can find out its what is it? Okay, it is which distribution can take negative random variables or negative values of a random. So okay, I think the way you have framed the question, right? So random variables will have the distribution, right? You can say that which random variable can take negative values, right? So in that
Yeah,
case, the normal distribution is the distribution it can take the negative values, right? Because the range of
yeah,
random variable, normal random variable is what? Minus infinity to plus infinity. So in that case, it can take any values from minus to plus. So that is one of the examples of random variable which can take any negative values, right? That is in the node. So there are other distributions also uh, which can take negative values. But mostly, see, if you think about the very common distributions like Bernoulli distribution, or any discrete, if you think about it, Bernoulli, Poisson, even the binomial, right? They take the positive random variable, positive values when they are the random variables, right? And similarly, I think in uniform distribution can take negative values. Fine, either it is a uniform discrete or it is a uniform continuous, right? So uniform distribution can take negative values also. Normal distribution can take negative values. Exponential is always greater than or equal to, so that will not take the negative values. All right. Okay. Yes.
Sir, one question, sir. I just want to ask, any sir practical example of this where it is used that we have this joint density function, then this function is another function of these two functions.
Hmm.
Any sir practical example you in your mind, sir?
So practical examples, see, it's not like it can be used anywhere, right? So it's like it has to be used for specific purposes, right? So mostly you will not see directly it is used, but it is used to derive certain expressions. So let's say you when you I don't know whether you have learned or have you taken the machine learning techniques as of now, but if you have, right, so
No, sir, I have not, sir. This is
yeah,
my
so
first mission.
yeah, so when you take the machine learning techniques, right, so you will learn about the various algorithms, right, like linear regression. Then you see the logistic regression, maybe this svms for classification, or some other unsupervised learning algorithm. So whenever you derive the loss functions for them, right, and you try to find out its, so there will use the optimization, the linear algebra you all learned, or these techniques, right? So I cannot tell you the exactly where it can be applied directly, but whenever you wanted to derive something, right? So let's say if you know this thing and if you wanted to go from one space to another space, right? In that way it can be used. Fine. So direct applications are not there. Like if I'll not tell you that, okay, whether, so suppose if I, in the mechanical engineering, let's say if you wanted, right, it's not like directly applied, but as far as this data science concerned, right, they, you will see whenever you derive some algorithms, right, that time they are useful to that time you will encounter this kind of techniques.
Yes, sir.
Yeah.
Thank you, sir.
So this is week 12, no?
Week 12. No, the this concept, I think it is from week 11, right? At the end, it is there. This transformations of two random variables. Yeah.
But
Now,
this for 11 and 12.
sorry.
This session is for only 11 and 12. Right?
Yes, yes. Today we'll talk about
Okay.
Sir, can you scroll up
Yeah.
to the end of the problem?
Yes.
So we find x and y and then we substitute in the function.
Yes. So this is x, right? This part was
Ah, sir. Yes.
this
And that
part.
is y.
This part was
W
x.
minus s.
Yeah. This was the x, and this was y. And I know the joint density of x and y was what? The joint density was this one, right? E 9 e to the power
E to the power
minus
plus
3
3
plus y. So I just substituted x as w plus z by 2, and plus y is w minus z.
w minus z.
So the denominator is same for them. So it is w plus z plus w minus z by 2, and z will get cancelled. 2w by 2 is w. So that is 3w, you can see here.
Yeah, okay, sir. Thank you. So these the normal probability problems and these transformation problems are the two types from
Yes.
week 11.
Yes. No, you can have the problems on discrete random variables, or like finding out the probabilities, right? So if given the
Yeah,
theory, how to find out the probabilities, only those kind of questions are there. So whatever you learned previously, right, in the
yes, sir.
stats
Stats
1,
2.
stats 2, not stats 1 also, I'd say that mostly stats 2 part, right, the central
Yeah,
limit,
stats 2, sir.
or maybe the Markov inequality, Chebyshev inequality, only, and that also is not like too tough problems. The simple ones are there from there.
Yeah, sir. But that one will come in week 12, right, sir? Estimation part. Inequality, Chebyshev.
Yeah, that is in week 12. Yes.
Yeah, okay.
I will write down the formulas for that, and if you want, like, if you have any questions from the previous year, or if I can see the questions in the mock, right, I'll solve that on that concept also. Fine.
Yeah, okay, sir.
Okay. Now,
Sir, sorry to interrupt you, sir. Just very little question, sir. For the final quiz, the weightage will be for week 9 to 12. Will be what percentage, sir? Basically, it will be
so
50%. Just like
yeah, you can think about it is in between 40 to 50%, and
okay. Thanks,
the
sir.
remaining weeks will be having yeah. So it's like kind of distributed. You may not find any questions from week 1, I think, calculus part little bit. You may find questions from PCA and SVD, or
Come again, sir. Not able to get you.
PCA and SVD. You may find questions like maybe theoretical questions, not to like find out the PCA entirely, right? Not that kind of questions. It's like applications of PCA possibly, and yeah, and I think some of the like the questions, right, like finding out the rank, finding out the nullity, those kind of questions from linear algebra.
Basically, so we can say 9 to 12, 50% approximate, and 1
Yes.
to 8, 50% approximate.
Yeah, you can think of. Maybe I'll give you the proper weightage at the end of the session. Maybe I'll just look at the question paper and maybe I'll let you know. Fine.
Thank you.
Okay. So let's okay, I'll not derive the expressions, but I'll just give you the brief idea about it. So we have seen the bivariate normal, right? So bivariate normal, right? So, and we have seen some properties of multivariate normal, and questions might come from there, right? So let's say the bivariate normal. Okay, so we have seen that z1 is a random variable which is normally distributed with mean as 0 and the variance as 1, and similarly z2 is another random variable which is, you can say that, is
Sir,
this. Yeah.
um, you had started with the support of the earlier question, right? Did we complete that? Or maybe I missed it.
No, I said that you can find out the support rate. That's what I just left it. Like you can actually substitute the values of x and y. I think one of the questions previously I have shown you how to find out the support rate.
Okay,
Uh,
no problem. Yeah.
if you have doubts, maybe I can take it later. That's fine. I will show you that also. It's not a problem. Okay, so let's say these two random variables are there and they are ID random variables. We have seen that, let's say uh, we wanted to find out its linear transforms, right? So let's say there is another. So if I have Z1 and Z2, can I find out its joint density if they are ID random variables? F Z1 Z2 of Z1 Z2. Is it known to me from this information?
Yes, yes, you can
Yes.
multiply both.
Yes, right. So it is known to me. Then if let's say x1 is a another random variable which is a function of z1 z2, which is, let's say, z1, and x2 is another random variable which is a function of z1 z2, like this, z2. And if let's say z is a vector which actually contains these two random variables z1 and z2, and when I say fz of z, that means I'm just talking about the joint density of z1 and z2, right? Let's say x is a random variable, or let's say x is a vector. Capital X is a vector with two random variables inside it, that is x1 and x2. And when I talk about fx of x, fx of x will be the joint density of x1 and x2, right? Just keep that in mind. And if I wanted to write this x1 and x2 in terms of matrix vector format or matrix format, how will I write it? Let's say x1 and x1 x2 can be written as, let's say, the vector, the matrix has, so this 1 0, these are the coefficients, and here row and root of 1 minus rho square of z1 z2. So if you can multiply this, right, you'll get this one at fine. So in a compact way, I think we have started with this. We said this is matrix A. If you have followed my lectures previously, I think we have said that this is matrix A, and then this vector x can be written as A Z. And now I know the density of Z, so I can write Z as what? A inverse x. Given that A inverse exists there, A inverse x. In that case, what will be the joint density of x? So fx of x will be 1 upon 2 pi uh, was 2 pi under root of determinant of sigma, right? And e to the power minus half x transpose sigma inverse x. I think we have derived to this equation, right? Okay. So the equation, if you want more details, you can actually watch the lectures previously. I have done that. But what is sigma here, right? Sigma is a covariance matrix. Sigma is the covariance matrix, and uh, how does it look like? So in general, in this problem, let's say if I take this particular z1 and row z1, or then in
So,
that,
sir,
yeah,
so you'll be sharing this. Sorry to disturb. So sharing this PDF, right?
yes, yes,
Okay.
I will share that. So if in this specific transformations, right, the covariance matrix will look like this: one row, row one, right? But in general, if I have different kind of transformations, right, so this is a covariance matrix, and this you can actually get it by uh, doing this AA transpose, right? So A is this matrix. If I this if I do the multiplication of A and A transpose, then I should get it the covariance matrix. But in general, this covariance matrix will be of this format. So A square, row AB, row AB, and B square. So if you remember, the covariance matrix should be a symmetric matrix. So that is there, and A and B are what? A and B are some constants, and row is also a constant, but it is special constant uh, which takes values between -1 and 1, right? So that's what I think we have already established. So, and suppose if x is az plus mu, right? Mu is some, again, the vector, right? The vector of constants. In that case, fx of x, the joint density of x, will be 1 upon 2 pi root of mod of determinant of sigma, then e to the power minus half. Here the changes will be this one: x minus mu transpose, right? X minus mu transpose sigma x minus sigma inverse x minus mu. So that will be your joint density in this case. Okay. Okay, and this was, we have established that this is the joint density of. But let's say uh, in case of a multivariate normal, and if I take the linear transformations of them, so multivariate normal means in that case uh, the z will be a vector of all z1 z2 to, let's say, so it will be a d-dimensional vector, let's say, and each of zi is what it uh, is normally distributed with mean 0 and variance as 1, or in other words, I can say that z1 z2 up to zd, they are IAD normal with. So in that case, will I get to know the fz of z? Yes. And how that will look like? That will be 1 upon 2 pi to the power, I think it is d by 2, again square root of determinant of sigma, right? And again it is e to the power minus uh, not sigma, so this is, it should be uh, because sigma is 1, right? This is sigma square, so this is 1 upon 2 pi to the power d, or 2 pi to the power d by 2 e to the power minus, I think it is a summation, right? So I think it is zi square by 2. Fine. So what is zi here? Length of this is what is, or I can say if I take a square, let me not take a square. I'll just take length of this vector. It will be z1 square plus z2 square to z3 square. Is that fine? I have this is okay, right? And if x is a vector again, so x is, okay, I'll write down what is x is there. So x is equal to az plus mu, and what is x here? X is a set of random variables x1 x2. So these are the new set of random variables. Each of them actually are the linear transforms of vectors or z basically, and mu is a constant vector, right? So I'll just write z plus mu. Then in that case, what will be my joint density of x? And that is nothing but 1 upon 2 pi to the power d by 2 square root of mod of determinant of sigma, then e to the power. So don't worry about this. This will not, you will not encounter this kind of very difficult. If you don't understand it, that is fine. Like you don't need to remember all of this. Fine. You will not encounter this anywhere in the question paper. But I'm just, to have the sense of it, I'm just writing it down. This looks very difficult, but this is not difficult as such. So what is the expectation of x? That is mu. I think covariance matrix of x, that is nothing but sigma, and that is you can actually achieve by A transpose, and x is distributed as normal with mean as a mu, so mu and covariance matrix sigma. But what is this mu here? It's a vector. Okay, it's a vector of, let's say, values mu1 mu2 up to say mu d. Fine. I hope this is understandable. So mu is a vector of d cross 1, and covariance matrix is a d cross t matrix. And based on this information for the multivariate normal, I think we have established 3 properties, and I'll write down all the properties. Suppose uh, y is a new random variable which is a function of x such that it is A transpose x, then in that case, what is the density or what is the distribution of y? So since x is distributed like this, x is normally distributed with mu and sigma, and A is a constant vector, right? So A here is a constant vector. What do you mean by constant vector? All values are real values, right? In that case, y, the distribution of y will be, n will be, so it is A transpose mu. It is okay, it is normal distributed with mean as A transpose mu, and the variance as A transpose sigma A. Okay.
Yes, sir.
And I think we have seen another thing as if y is another random variable, if it is like this, and b is a d cross d matrix, so it is a d cross d matrix, the constant vector, and the dimensions are d cross 1 here. In that case, what is the distribution of y? So y will be distributed like this, normally distributed with b mu, and it will be a sigma, not a, sorry, b, it is b sigma b transpose. And the third property is that if xi and xj, they are dependent, then the covariance matrix, right? The covariance of, or covariance between x and xi and xj, that is this quantity is equal to 0. And this is true, the converse is true. If the covariance is 0, then they are independent. This is possible only in the case of multivariate normal. That means in our case it is possible. Okay, so this is it on the so let us see if we have any questions in the interim mock. If it is there, I'll try to solve that.
So can you
Like
please show
I
the
should
slide
not get
again?
to.
Yes, yes. Slider.
So are these like conditions?
Thank you, sir.
Sorry.
Are these like conditions?
Okay, okay. Can you? I don't understand. You can mute and just let me know. I don't understand what you said. You can mute, unmute. Sorry, unmute and tell me. Who is speaking? Are these conditions? You can say that it's not conditions. It's kind of a properties, right? So these are the properties. Properties. So it's like if I know x is distributed like this, right? And if I define a new random variable y, which is a transpose x, then what will be the distribution of y? So this is going to be the distribution of y. Right? X is distributed as normal, mu and sigma, and it's like very straightforward, right? If I take the expectation of y, what is the expectation of y in general? It will be expectation of a transpose x, right? And if
A
it is a
transpose with AX.
uh, so a is a constant, right? So then it
Yeah.
is
So
transpose outside, and it is expectation of x. So what is the expectation of x here? Mu,
mu.
right? And then a transpose mu. So that is here.
Yeah.
And
Okay.
similarly, you can actually argue about variance.
Yeah. Got it.
Yes. Right? So it's not like very different from we have learned previously. These are the kind of yeah, it's just I have defined a new random variable y, which is like this and like this, right? Maybe I think you can, yeah.
Sir, for KKT conditions, no, there is some notational difference in a little bit difference in tutorial and lecture. Can can you
Okay,
explain that?
after this, yeah, maybe I'll after this, right? Maybe we can discuss about that also. Fine. Anyway, that will be discussed in the on the Saturday session. But anyway, if I get the time right, I'll just discuss that here also. Not an issue.
Is there any more revision session?
Yeah, on Saturday it is there.
For which weeks?
9 and 10. Okay, this is the questions based on whatever we have learned, right? So let's say z1 and z2 are the IID normal, right, with 0 and 1, and x1 is defined as z1 plus 3z2 minus 2.
Sir,
Yeah.
instead of not, can you do AX?
So yeah, that's what I'm saying. If you have any questions, right, you can let me know. I'll solve them.
Yeah, I'll send the link, sir. That's the website.
Okay, that's fine. So do I need to solve this? Maybe we can discuss this, and then I can come to that other question. Is that fine? I can. It's like it will take only 2 3 minutes.
Yeah,
Uh,
give me a second. I'll get the link.
yeah, yeah. Meanwhile, you can just share the link. Yeah. So let's say z1 and z2 are like this. I wanted to find out the distribution of this vector, right? Joint density of this. So what is given to me? So the question is z1 is normally distributed with mean 0 1. Z2 is normally distributed with 0 1. And what is x1? X1 is a linear combination, right? So x1 equal to z1 plus
3z2 minus 2.
3z2 minus 2. Right. 3z2 minus 2. And uh, x2 is z1 minus 2z2 plus 1. Z1 minus 2z2 plus 1. Okay. Now, x is a this vector, right? X1, x2. So how can I write it in terms of z1, z2? So I'll write down its coefficients. So it will be 1, 3, 1 and minus 2, right? That is z1, z2 plus this vector, which is minus 2 and 1, like h Is that fine? Can I write x1 and x2 like this in the vector matrix format? Yes, right? So x
Yes.
is equal to, let's say this is a z plus mu. So if I know z1 z2 distribution, and if this is the thing, right? So then x will be, I know x will be normal distributed with mean as which one? This, right? This mu, let's say. So mean minus 2 and 1. And what will be the covariance here? So the covariance matrix will be, because since this is A, right? So the covariance matrix is A transpose, correct? So what is A? It's 1, 3, 1 minus 2, and A transpose is 1, 1, 3 minus 2. So that is going to be, it is what? 1 plus 9 is 10, 1 minus 6, right? 1 minus 6 is minus 5, 1 plus 3 is 4, and minus, sorry,
Sir,
I
it
might,
should be -1.
yeah, 1 into minus 6, right?
It is symmetric matrix. No?
Minus 5, yeah. And here it is 1 plus 4, which is 5. Is that fine? So here it is 10 minus 5 minus 5 and 5. So that is your answer. So the distribution of x is this. Is that all right? Any issues? And if not,
Sir,
so
here we can't. Sir, here we can't do one thing, right?
yeah.
Like, uh, can you just go up? Like, can you just go to the expression like of x1 and x2? So here we can't find expectation of x1 as expectation of z1 plus 3
That you
expectation
can
of z2
find.
minus.
So that you can find. So it will be like expectation of let's say x1, right? X1 is equal to
Right.
what? It is expectation of
1
z1 plus
plus 3
expectation of 3 times expectation of z2,
minus
and
2.
right. So what is z1? It is 0, 0.
Oh,
That is going
z1.
to,
Okay, correct. We can do it.
and expectation of x2 is also 1, right? So now if you can think about it, and that is what we have written, right? So it is minus 2 and 1. Variance also you can find, but the covariance it is difficult to find. Again, you can find it out. It's not like difficult, but then so variance of x1 is what? It is
1.
uh,
Expectation. There is
variance of
1.
z1 plus 9 times variance of z2, and
Yes, yes,
variance
yes.
of x2 is variance of z1
z1 plus 4
plus
times variance.
1
2 times.
4 times
4.
variance of z2.
Z.
So that is variance of z1 is 1 plus 9 times variance of z1 is again 9. So it is 10 here. And what is variance of z1? 1 plus 4. So that is 5, right? So,
Yes.
but the covariance matrix will look like what? It is sigma 1 square. Then the covariance between sigma 1, sigma 2, or okay, maybe I'll just write in terms of z1, z2. So the sigma matrix will look like what? Variance of
Variance
z1,
x1, z1.
variance of z1, z2, then the covariance of z1, z2, and the variance of z2. So far we have found out variance of z1 and variance of z2, right?
It will be
So
variance of x1, right, sir?
yeah, okay, fine, yeah, sorry, it's just okay, so x1 and x1 x2 here, and here x1 x2 and like x2, yeah, and here it will be 10 and 4, but I need to find out covariance. So
10
how
and 5, sir.
yeah,
10 and 5.
10 and 5, okay, okay, that's okay, okay, fine, okay, that is 10 and 5, but then how will you find it out, the covariance here? So x1 and x2 are basically not the independent ones, right?
Right.
So
So,
but so then in that case, what will be the expression for covariance of z1 and z2, or covariance between x1 and x2?
expectation of x1, x2 minus expectation of x1
Yeah,
and
so
x2.
that way, right? So then it will become the cumbersome task, right?
Yeah, it will become a big task, correct?
So otherwise, we know that, like we know that how this is going to be, right? I think that way is easier.
Sir, we already know variance of x1 and variance of x2. We can just plug in the formula. Variance of x1 plus x2 is equal to variance of x1 plus variance of x2 plus covariance.
So you, I think you are speaking right. I don't. I understand. I'm just able to hear you. Like you're saying that I know variance of x1 and I know variance of x2. What is later on? I don't. I was not.
Like we can just plug in the formula into the formula. We can just find variance of x1 plus x2,
Uh,
and we find the covariance from there. Like, we already know variance of x1 and variance of x2.
okay. What is the formula of covariance of x1 and x2?
Like an variance of x1 plus x2 is equal to variance of x1 plus variance of x2 plus 2 times the covariance.
I don't think that is a formula. I think you just need to.
Yeah, that is there. Like for like non-independent
Yeah,
variables, random variables,
yeah, 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 yeah.
we
That is
can.
what like, you can actually. Yeah, that is okay. I understand what you are saying. You can substitute there, but again, you should know it and you should do it properly, right? That is fine. It will. So anyway, this is whatever we have found out. This also, right? It's not like magically came in, right? So it is also like that only. You can use it. No issues with that. If you are comfortable with that, that is not a problem. Okay. Yeah. Yeah. Any. Okay. Okay. This one is the link you said. Okay. Which questions? Can you tell me the exact questions? See, I can't go through it like everything, right? You just let me know what are the exact questions you want me to solve. This one.
Question number 4 is from week 11, sir.
Do you want me to solve this one? This is fine. Question 4.
Yeah, okay, sir.
So x1, y are the two independent random variables where x is normally distributed with mean 2 and the variance 5, and y is a normal distribution with mean 5 and variance 9. Given that z is equals to 3x minus 2y, find the probability of z is greater than 8. That is the question. So this question actually is solved by using the uh, variate, right? So the standard normal variate. Let us say I'll just solve that. This question from what is given to me as x is normal distributed with 2 5 and 5 2 5 and y is, I'm not going too fast, right? Just let me know if I'm going fast. uh, z is equals to 3x minus, sorry, z is equal to 3x minus 2y, and I need to find out what probability that so z is a new random variable which is like which is a linear combination of x and y. Then in that case, probability of z is greater than 8. That is what I need to find it out. Okay. So what do you do first? You can actually find out the distribution of z first, right? Is that okay? So if x and y are they the independent random variables? Yes, they are the independent random variables. In that case, if I use our uh, earlier, if they are independent, right, and if x is x and y, or if if z is a linear combination of that, how do you find out? Or in general also you can find it out. What is the expectation of z? It is going to be 3 times expectation of x minus 2 times expectation of y. Okay, so 3 times expectation of x is what? 2, and minus 2 times expectation of y is this 5. So it is 6 minus 10, which is minus 4. And what is variance of z? That is 9 times variance of x uh, plus 4 times variance of y. So variance of x is
Fine.
9 into 5 plus variance of y is 9. So it is 4 into 9. So that is
81.
81. Huh? Okay. So what is the distribution of z? Z is going to be normally distributed because it's a linear combination of two normals, right? So when it is a linear combination of two normals, the uh, the, the the distribution you will find it out, that also will be a normal distribution, but with the mean as actually the mean should be translated, right? So the mean is going to be -4, and uh, the variance is going to be 81 here. Now, what is asked to me? I need to find out what is the probability that z is greater than 8. So if this is normal distributed, how to find out the probabilities of a normal distribution? Make it as a standard normal.
Standard number.
Yeah. So the standard normal will be what? So okay. Now I need to find out probability that z is greater than 8. So I can do one thing, as I can find out 1 minus probability that z is less than 8, less than or equal to 8, let's say. Okay. This is your fz, right? Okay, but I not fz right now. We'll convert that. So how to make this standard normal?
Z minus expectation of Z
Minus of mu divided by, so let's say this is mu, and this is
divided by 9.
uh,
9.
sigma square, right? So it is root of sigma square, so I can say sigma equal to 8. And if I substitute these values here, so it is 1 minus probability that uh, z minus of -4, so that is z plus 4. Okay, I think we should do the same thing on both sides, right? And 8 minus mu by sigma, so z by 4, z
Sir,
plus
8 plus 4.
9. No, this is, I said this mu only, this mu, not 4,
It's -4, right?
minus of,
Okay.
so that will be 8 plus 4 by 9. Is that okay? And this term here, right, this is your actually is a standard normal variate, right? So I generally we use z as a notation, but let's say I'll just write down standard normal variate. Okay, I hope you understand that. That is going to be 1 minus probability that, or I can just write in terms of fz, that should be fz of, what is this, 12 by 9, how much it is, 4 by 3, right? And then you can find out, so from the values given, right, what is okay, 4 by 3 is 1 minus fz of, I think it is 1.333, and then it is 1 minus if 1.33 is this one, 0.90824, 0.90824, and you can calculate it. I think it is 6 uh, 7 7 1 9, okay, is it 8? No, sorry, I think I had a mistake. So how much it is, 1.00, right? So it is okay, I think it is 6
0.08176.
7 1 how much, 9, right? 9 here,
999, sorry.
90 and 0.09176 kind of this value. I don't know whether it is correct, but yeah, I think it should be correct if I'm not done any mistake. That is your probability that z is greater than 8. Is that okay? I hope you understand that. So first of all, we have found out the distribution of this z, and then we found out its probabilities by making it into standard normal variate.
Sir, then why did they give so many values?
Confuse you, right? Which one you should do it? Which one you should use it? If I give you directly this one value, then what is the need of doing all the other calculations, right? I can just write 1 minus of this, right?
Mm-hmm.
Correct, right? So yeah, that's why. Any other question you need me to solve?
Sir, week 10 GA last question can take that. So,
No, that I'll come to the later. Like, just give me like now, week 11 and 12. That's what I'm saying right now. 5 and 6, huh? Okay. Yeah. Yes. Riddhika.
Sir, I wanted to ask one question, like how we need to find the range when doing the transformation of random variables. Like I have a question from a PYQ. I was
Yeah.
able to solve the transformation, but I could not guess that how to take the range. Can I send it in the
Uh,
chat box?
yes. Yes. So it is not like you need to guess it. You will have to find it out. I think in one of the things I have told you, but that's fine. I'll just do it for you. Okay, just give me a minute. I'll be coming back in 2 minutes. We'll do solve first these two questions, right? I think, and then I'll come to your question, Deepika. So that is related to how to find out the range, right? I'll solve that. Okay, just give me 2 minutes. I'll be coming back. Okay. Let's see this question. The company has scheduled the interviews for job applicants, and 60 people have confirmed their interview slots. Each applicant attends the interview with a probability of 5 by 6. Let X denote the number of people who actually attend the interview. Using the Chebyshev's inequality, find a lower bound on this probability that so I need to find out the lower bound, right? What is okay? Before finding out formula, let us try to understand what is given to me. So each of the person who gives interview, right, out of the 60 interviews, what is the probability that the applicant will let's say this question, right? What is the probability that the applicant will uh, the probability that applicant will attend the interview is 5 by 6. Okay. Yeah. Fine. So what is the question now? Uh, Now the thing is, if X denote the number of people who actually attend the interview using the Chebyshev inequality. So how many people are there in this question? 60. So let us say each of them will have the success probability of success as 5 by 6. That means attending the interviews. So let us denote them by this random variable. So x1, x2, x3. These are the samples up to what x60 because there are total 60 people. Let's say they attend the interviews with IID Barnauli. So this is the distribution with probability as 5 by 6, right? Uh, if I take a sum, right? So how many people can actually attend the interview? So the number of people who attend interviews will be, let's say, it's a new random variable y, which is x1, x2, x3, up to the so each of this x1 is a Bernoulli random variable, right? So 0 denotes the person does not attend the interview. 1 denotes that the person attends the interview. So how many people have attended the interview out of the 60 will be just the sum of the people or some of the random variables associated with them. Fine. So then this y will follow a binomial distribution with n as equals to 60 and p as equals to 5 by 6. Now, if that is the situation, in that case, I need to find. So I need to find out the Chebyshev inequality, and I know if I wanted to find the lower bounds on the Chebyshev inequality or the upper bound on Chebyshev inequality, I need to find out the two quantities, which are those: the expectation of a random variable and the variance of a random variable. In this case, the expectation of y will be what? It is just n into p because it's a binomial random variable. So n is equals to 60 and the probability of success is 5 by 6. So that means the expectation will be equals to 50. Similarly, the variance of y will be, since it is a binomial random variable, the variance will be n p into 1 minus p. So that is nothing but 60 into 5 by 6 into 1 by 6. So that is n 50 by 6. Right? That is going to be my variance. So what is Chebyshev inequality? Okay, Chebyshev inequality gives me the upper bound on this. So Chebyshev's inequality, right? And what is that? That is nothing but probability that mod of y minus, let's say, I'll write this as mu, and this is, let's say, sigma square. Uh, so y minus mu is less than or equal to, let's say, k is equals to higher or is nothing but greater than or equal to sigma square by k square, right? But I don't need upper bound. What I need is the lower bound, right? So I need this quantity, uh, or I think so. I think that is also fine, right? So this is, yeah, this is going to give me the lower bound only, right? Yeah, this is going to give me the lower bound. So okay, I don't need to do anything else here. So just in this case, I need probability of y minus 50 greater than or equal to what is k here? K is, okay. I think I need, yeah, I need,
But we'll have to find
yeah,
less than equal to 6.
yes. So that is actually 1 minus, right? So it is 1
Yeah,
minus
1 minus 5.
probability of mod of y minus 60 less than or equal to 6, basically. And that is nothing but, so I can actually write this in terms of or in this way as, how will I write this? Or okay, I need this one. So that means 1 minus mod of y minus 50 less than or equal to 6 is equal to, basically it is 1 minus probability that mod of 1 minus 50 greater than or equal to 6, and that is equal to 1 minus, what is the variance of y? We already have calculated, that is 50 by 6. Okay, I'll write down 6 sigma square by k square. It is 1 minus, should say that, uh, that is 1 minus sigma square is 50 by 6, and what is k? K is this, right? So it is 6 square. So what will happen? It is 1 minus, I think it is 50 by 6 cube, right? What is the value of 6 cube? Or maybe I'll just write like this, you can find it out. So it is probability that y minus 50 less than or equal to 6. This is what gives me the lower bound on the probability. So I think 6 cube is 216. So
Yes, sir. 216.
that will be 1 minus 50 by 216. If I just calculate it, is 216 minus 50 is around 170, no, 164, right? 164 by 216. That is the answer.
166 by
164. 164, right? 216.
166, right? 216 minus 50.
216 minus 50 is, yeah, 166. Yeah. Should be 166 by 216. And that is the probability of, or that gives me the lower bound on this probability. I hope my answer will be correct. You just cross check it later on, but that's how you will have to solve it.
Yeah, so just to switch to learning mode and check answer, sir.
Huh?
Below that website, there it's also in that website.
Where it is?
Learning mode, exam mode. No. Here. Left. Above. Uh, View question paper summary about that learning mode.
I don't know where it is.
Learning. Yeah, exam mode, learning mode.
Okay,
Learning
it's
mode.
okay. It's okay. You can check it later on. Huh? I don't know. I am not able to see it here right
Yeah,
now. I understand you are saying something to me, but I'm not able to see this one.
yes, and to the left of the
Learning mode,
answer,
sir. Learning mode.
learning mode, to the left of the answer box. Yeah, learning mode. You see exam mode, right, sir?
Okay. Here.
Ah, check answer.
Okay, but somebody has to do this, right? So, but I think it
Yeah,
will
zero,
count that.
Yes, it is coming 0.78 something.
Yeah, it will come.
7678.
Right. So this question, right? Let us go through this question. So the
Yes, sir.
failure rate of lambda. Okay. So u1, u2 to un. These are the random variables, right? And these are the IID random variables with uh, with the distribution of exponential, and learning rate is lambda here. Okay. And it what uh, uh, each of this random variable denotes here, it is the observed lifetime of the bulb, right? Or laser operating at higher power. I think that is what I think. It's a observed lifetime of the laser, let's say, of higher power. And the sample given to me is u1, u2, u3, u4, and u5. These are the 5 samples given to me. The values which are there for their observed lifetime, they are 2, 5, 3, 1, and 8. I need to find out the maximum likelihood estimator of lambda, right? So yeah, this is also a nice question. So let's see how to solve that. So u1, u1, u2, and up to u1. These are the IID random variables with uh, exponential distribution, and the learning rate is lambda here. Okay. Now I need to find out that what I need to find out. I need to find out its maximum likelihood estimator. For that, I need to find out its likelihood. So likelihood of this will be, and okay, in this case likelihood of lambda, because lambda is a parameter here. So likelihood of this lambda is equal to what? It's a product, right? So product of I equals to 1 to n, the PDFs, or
Lambda v
lambda
for
to the power minus
minus
lambda
lambda n.
ui, right? And that is going to be the product. Next step is what? I need to find out its log likelihood. So log likelihood of lambda is nothing but what? It will convert this into the summation, right? uh, okay, I think I have done one mistake here. When I okay this I when I wrote it, right, let us try to find out its product first. So the product will be lambda to the power n and e to the power minus lambda summation of I equal to 1 to n ui. Okay. So then if I just apply logarithm over this function, right, then what I'll get, it is n log of lambda minus lambda into summation of I equal to 1 to n ui. Okay. The next step is either I can do the maximization of this, or I can, if I wanted to do the minimization, what I need to do is I will take the negative of log likelihood. That negative of this log likelihood will be minus n log of lambda plus lambda summation of I equals to 1 to n ui. Okay. Then the next step, let us say this entire function is h of lambda, right? And the next step will be what? To differentiate this with respect to the parameter that is lambda here and equate it to 0. So what that step will be then? It will be minus n upon lambda plus, so if I differentiate this with lambda, what I'll get? Only this part, right? The summation. So plus sum of I equal to 1 to n ui, that is equal to 0. Okay. And if I do that, right, so n by lambda will be equal to summation of I equals to 1 to n ui, but I need to find out the estimator for lambda, so that lambda hat will be equal to nothing but it is n divided by summation of I equals to 1 to n ui. So this is the estimator for lambda. In our example, what is the number of samples given to me? 5.
Right.
And what are those values? Okay, total number of samples are 5. And what are those? U1 is equals to 2. U1 equals to 2. U2 equals to 3. U3
No,
equals to 1.
5, sir. U2 is equals to 5.
Okay, 2, 5, 3, 1 eta. 2, 5, 3, 1 and uh, uh, 2, oh, okay. So U1 is equals to 2. U2 is equals to 3. No, 5, right?
U2 is equals to 5.
5, 3 is 2, 5, 3,
3,
1
1,
and
8.
3. Now, what will be my lambda hat? The estimator in this case, that will be just 5 divided by the sum of all of them. So 2 plus 5 plus 3 plus 1 plus 8. So it is 9 plus 3, 12, 12 plus 2, 14, 14 plus 5, 19. That is 5 by 19. That is my estimate. So I hope you understand those steps. So first of all, find out its likelihood. It is a product of their PMFs or PDFs, whatever. Then take its logarithm. You can directly differentiate this function also, and equate it to 0 with respect to whatever the parameter is there. But this when you take the negative of likelihood, right? So that maximization problem will become the minimization problem, and the similar steps will follow. That is differentiating with respect to that parameter here, and then equating it to 0. All right. Okay. Okay. I think some question was there from Ritika, right?
Yes, sir. Sorry to interrupt you, sir. I just have a very little query, sir. For the week, sir, 11 and 12, there is a summary by Anand, sir. So can you little bit elaborate on the main points once again?
I don't know if you. I don't have right now the summary. If you want,
Because this is on the link, I can just send the links right away. You can find week-wise summary, sir. So that is
week
week-wise
5.
curated. Week-wise, not
Yes.
week 5, sir.
Ah,
Week-wise.
okay.
WISE. I am just sending the link in the chat, sir. So that will be good revision, sir. Basically, the basic concept, sir.
Sure. Sure. I'll let
Oh,
you know which are the important topics. Fine. Okay.
I'm just sending the link, sir.
Yeah. 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 Before that, I'll just take this one. Rudika, which questions you want me to solve?
So question 13. Not solve, sir, just how to calculate the range. I
The
want to
support.
know.
Support. Okay.
Yes, sir, support.
Number 30 is this one.
Yes, sir,
Okay.
this one.
Okay. I'll just. I hope I'll not. Maybe I'll not. You may be able to solve this one. You just need this part, right? How that sum.
Yes, sir. Only the
I
support.
think that solution is available there also. But yeah, that's okay. If you don't get it, that's fine. So let us say this is your joint density function, and what is the range of x and y between 0 to 3, right? Right. So what is x? X is between 0 to 3, and y is between
0 to 3.
3. So what is the support of x and y here in this case? So let's say it is 3 here, and let's say this is x and this y, right? So the support of x and y here is this rectangular box, right? What do you mean by support? Over this region, the joint density occurs, right? And I think that joint density is equal to, I think it is 1 by 27 x plus y, right? That is what uh, I hope all of you understand what is the support means, right? Outside of the support, that is equal to 0, correct? On the support, this
So,
is the joint density, and we can find out different probabilities, right? If I wanted to find a probability of x being 0, or between x is between 0 to 1 and y is between 0 to 1, then how does that will be? So that, I think, this portion, right? You just integrate over this portion, or you just directly multiply this or substituting these values, right? That also you can do, but that is what the support means here in this case. Okay, now I wanted to
the
find
support means the bonds, right?
support means what?
The bonds, boundary.
It's not like boundary, it's like over this, if this is joint density, right? Anyway, this two random variables which are the jointly distributed, that means x and y affect each other, right? So how does they are affecting is like this. So if I wanted to find out its probability, so fxy is a function which is actually is a perpendicular to this, so it's kind of like that. So if I wanted to show you it in 3D, right, it is like this. So let's say x and y are here, and fxy is over here, right? And let's say this is the support. How this fxy, I don't know. So this is kind of a linear, right? I'm not sure whether it is a triangle, or actually it will not be a rectangle, but let's say kind of like this. Fine. So over here, you can able to find out the density outside, right? Let's say for any values of x and y other than between 0 and 3, you will get the value of 0 there, right? So support is that thing within which you can say that the probabilities exist, outside of which, right? So at let's say if I wanted to find a probability between this point and this point, right? Let's say for this part, right, that is equal to 0. So the probability does not exist outside the support. Understand? So kind of in simple terms, if I trying to say that this is a range of the random variable, right? So suppose when I say x is Bernoulli, or let's say x is, okay, maybe simple. I'll make it more simple. Suppose x is a discrete random variable which takes values 0 and 1, okay, like kind of a Bernoulli, let's say, and it is zero point 0.5 and zero point 0.3. So what is the probability that x equals to 2? What do you say about it? It is equal to
0.
0, right? What is the probability
Zero.
that x equal to 3?
Zero.
0.
0.
So what is the probability of x equal to minus 1? 0. So,
Zero.
so only for these two values the probability exists. For other values it is going to be 0. So kind of saying like this, if I say in other words, it's, or uh, the formula
We
of,
can say the
yeah,
we can say the range within which the probability varies. That we
yeah,
can say.
yes. So it is like that 1 upon 27 x plus y when x is between 0 to 3 and y is between 0 to 3 and 0 otherwise, right? So this is how we can write the probability. So maybe I will this fxy of x comma y. So the probability is existed only when x is between 0 to 3 and y is between 0 to 3. And how does it exist? The value of probability is like this: 1 by 27 x plus y, right? And it is 0 otherwise. Otherwise means for any other values of x and y, the probability will not be existing. Okay. Have you checked whether this probability of mass function is uh, or this, well, probability density function is valid? Is it checked? I think it is valid, but you should check it. That's fine. What about this? Define u equal to x plus y and v equals to x minus y. So what is u here? U is x plus y and v is x minus y. Fine. So if the joint density is in these terms, so what is the expression of x? X is, I think it will be u plus v by 2 and y is u minus v by 2. Fine. Okay. Now we have two extreme values for x and y. What are those? 0 and 3, right? So let us say x equal to 0. What will be the value of y or u? So that will be 0 equal to u plus v by 2, and that I can say that in terms of u, let's say, or in terms
Minus b.
or in terms of v as
Minus b.
v is equal to
Minus u.
and when x equal to 3, okay, this will be 3 equal to
U- b equal to 6 minus u.
3 equal to uh, u plus v by 2. So that is, that case v equal to
6 minus u.
fine. And when y equal to 0, then we'll plug it into the equation 2, that is equal to u minus v by 2, and that in that case v is equals to u, and y equal to 3, y equal to 3, so y equal to 3 is 3 equal to u minus v by 2, and that gives me what, v as I think u minus 6, u minus 6, right? So it should be u. Okay, is that correct? 6 and yeah. So if I plot all of these lines, right, how does that look like? So how does this support will look like? So let's say v is my y-axis and u is my x-axis. So v equal to minus u. What is that line? Okay, let us plot this plus first. U equal to v, and that is this one. U equal to v, right? This is, let's say, what about v equal to u minus 6? Where that will be there? So when v equal to 0, in that case u will be equal to 6, right?
6.
So it will cut the u axis at 6 when u is 0. So that means this line is parallel to this, the above line, and that is v equal to u minus 6, and that is, I think it will cut at 6 here. Okay. What about v equal to minus u? V equal to minus u, it's a negative slope. So I think that has to be like this, uh, something like this, right? Uh,
V equal to minus u will pass from the origin, right?
no, it shouldn't, right?
V equal to minus u.
Ah, yeah, okay, okay, yeah, right. Okay, so it has to pass. Okay, sorry, just a minute. I will draw this properly. Yeah, now I think I should. Yeah, that has to be here, the negative slope, and it will pass through this. Okay, and that is your uh, v equal to minus u. I am writing v and you save, but I hope you understand this. And the next line is 6 minus u. So 6 minus u will be cutting at, so when u equal to 0, the v equal to 6. So that is going to be this parallel line. So that will be this parallel line. I think it will cut at 6 here. Okay. So the portion here, right? That is what your support. Correct. This is your support. Support for u and v. Now the question is, how should I say this support, right? So either I can say that u is going from where to where in this case.
0 to 6.
U is between 0 to 6, right? U is between 0 to 6. Now U is between 0 to 6. So okay, I think all of this is, you can think the first and the third equation, so it is there. What about V now? So there are, this is a piecewise function, right? So you can just cut this into two parts right now. Let's say this, I have cut it here till now. Fine. So can you just tell me how this will, how this will go? Uh, 0 to U in the first half, right? Until,
First half.
yeah, and
Yeah.
later.
And then in the later half, it will follow this line, this green line.
So 3 to minus 6, right? Or
Something, yeah, yeah, yeah. V minus 6, something like that. To
so
6.
so first of all, it will go from here to here, and then it will go from here to here, right? And
Right.
similarly, it is like here also. It actually it follows this also, right? This path also. So how
Yes.
can I write? Let us try to understand using this. Uh, so what will be the value of u v? So if I just take this first example, how does it will look like, right? So minus u is between, or we will take the values of minus v2. So let us understand what is this. It is minus u to v, right? And what is the range of u? U is actually taking values from 0 to 6, right? 0 to 6. Fine. So if this is there, it is saying that it should be less than or v is greater than or equal to minus u. What does that mean between 0 to 6? So as I move from 0 to 6 here, I should we should take, or it should be greater than or equal to minus u. Which part it is actually indicating here? Are you able to follow this? So it's like all the negative slopes, right? From here to here and from here to here, right? Is this correct?
Yes.
These two parts, because it's a negative slope, right? It's showing the negative slope, and this part actually is showing me what?
Positive.
Positive. So that will be these things. So what it is saying is that if you takes the values between 0 to 6, uh, it will actually follow this also, and it will follow the same time, it will be followed this also, right? So for what values it will be less than or equal to v, and for what values it is, so actually I can think about this as, so we will take values, or v is greater than or equal to minus u, and v is less than or equal to plus u. Fine. So in this, right, if you think about it, if it is greater than 3, right, or okay, if u is greater than 3, what will happen? So we will be either greater than minus 3, or we will be either less than or equal to 3. Is that fine? Is that okay?
Yes, yes.
I'm just talking about this
Yes,
portion
sir.
only, which is between 3 and 6. So v either this, or right. So v is either greater than or equal to minus 3, and v is less than or equal to 3. So v is less than or equal to minus 3. Which region is this?
Is less than, is greater than equal to minus 3, right?
This one is
Less.
this one plus this one, right? If I say add, if I add this two,
Okay.
is that fine for
Yes,
all of you?
yes, yes, yes. Less than
V
equal to
V
3.
is greater than or equal to minus 3 actually is like it's showing this portion, right?
Yes, yes,
And plus this
yes, yes,
portion. And there is
yes.
another, let's say u is less than or equal to 3, right? Or maybe you can say that it is between 0 to 3. So when u is between 0 to 3, right? Okay, basically,
Yeah.
whatever we are showing here, it is between, u is between 3 and 6. And if u is between 0 and 3, right, it will show this portion.
Yes, yes.
So that is actually this portion. So you can I think it will be, the option A should be correct. No, if okay, again you will have to think about what is the joint density coming for you. It is u by 54
Sir,
or u.
it's U by 54.
And then I think this option A will be the correct option.
Yes, sir, it's the correct one.
But do you understand that how you have reached there?
Yes, sir.
Okay. Okay. Any other questions you want me to? Okay. I think before that, I think somebody has shared the list with me. Okay. What topics you need to follow? Is that what you said, right?
Yes, it will be thankful, sir, if you just once again recapitulate because I watched a video some times ago that the things become out of mind because I'm working professional. So we'll
Yeah.
be thankful if you just because you are in touch always. So it will be
Yeah. Okay. So I
grateful
think
you can recapitulate the things, sir.
yeah, I think you should go through this first, the vector side, this part. You wanted, actually you don't want all of this, but you whatever we have covered it today. So I think I have covered it all of this, right? Bivariate, multivariate, how the standard normal vector will be there. So you don't need all the derivations here, but you should understand what is happening there. And I think this part is important. MLE, I think that is also important. We have covered it, that also. This is, you can skip maybe linear regression with the Gaussian noise, right? If you can skip that part, I don't think you will have that issue. This particularly this part, you will not find that issue. GMM you can skip. Okay, we have not asked any questions on GMM, so you can skip that. uh, okay, CLT we have covered it. Okay, just give me 2 minutes, maybe I can tell you exactly what portion is needed for your just give me a minute. My screen visible? Is it visible?
No, sir, no,
No,
sir,
sir.
not with.
No, sir.
Okay, that is great then. So, this is your MLF, right? MLF went up. Okay, I'll be talking about what is the distribution of week 11 and 12. Okay, Markov Chebyshev will be important. I think one of the questions we have solved is solving that, finding out
Sir,
the
your
probability.
screen is still not visible, sir. Are you sharing
Yeah,
anything?
no, no, no.
Okay,
I'm not
okay,
sharing.
fine.
I'm just seeing. Projection part also you just go through it. Okay, how to projections. Then you should know how to find out conditional probabilities, and given the joint density, how to compute variance. Will you be able to do that?
So
Yes,
what,
sir.
sir? What did you say?
Okay. Just a minute. I'll tell you exactly what topics you can cover and you can left, so that it will be easier for you also. Okay, so I'll tell you exactly what topics you can actually cover here, right? So, okay, you should know the transformations of random variable. I think we have seen that, right, today. The transformations of random variable, that also you should
Yes, sir, exactly.
go through it.
First topic was that only.
Yeah, then you should go through this MLE, maximum likelihood estimate. That also is important. I one question I have solved it. So you just maybe try to solve that kind of questions. You should know this also. Given the joint density, right? That is what transformations of two random variable, that you should be able to solve it. What else you need to solve is, or maybe you should be able to solve is. I have solved some problem in between, right? The probability, how to find the probability. Uh, yeah, this kind of questions. So you should practice this also. given x and y, and if z is this thing, right? You need to find out that product of this. This also is a important questions. You can solve that, or you should go through it. What is the inequalities you should know? The two inequalities, basically Markov and Chebyshev. That is basically important one. Other things you can skip here, not an issue. You don't need the CLT also, but you should know how to convert that variable into a standard normal variable, because that is important in solving that kind of problems. I hope it is clear now. What are the
Exactly, yes, sir.
topics you can
Yeah.
like, or you should be able to solve the problems. So the topics, I'll write it down here again. So
So, so the topic which we can skip is that's a linear regression with Gaussian node, the
linear
Gaussian
regression,
mixture model.
Gaussian mixture model you can skip. Don't you don't need.
Linear regression with Gaussian nodes, so that can be skipped, sir.
Yes, both can
Okay.
be skipped. So you should be transformations of two random uh, variables, then multivariate and bivariate, right? That also you should go through at least the questions. No need to go through the derivations. Then Markov and Chebyshev, Chebyshev inequalities, right? And then you should be able to. Okay, just give me a minute. Okay, so transformations of two random variables, Markov and Chebyshev inequality. I think you should know how to find out, let's say, given the two random variables, how to find probability that z is less than or equal to 8 or like that, right? So that kind of problems. That is, you should know how to convert that into a standard normal variable. So that is x minus mu by what, sigma, right? And then you should know how to find out the probabilities. You should know how to find out the conditional probabilities. Yes. And what else is remaining? Yeah, I think these are the topics from week 11 and
Central
12.
limit is not really-
Central limit is not needed. The questions are
okay.
central limit there, so don't worry about it. Okay. What else you wanted me to solve? Or I think these are the topics. These are the broad topics you should.
And even weak law of large numbers and all those things are not
Required.
there.
That is like understanding purpose. I
Uh-huh.
think you guys have already studied those in
Yes, yes.
stats, right? Stats too, and then
Yes.
the great details. So you don't need that into this.
Sir, request to just to look at week 11 also, sir, so that we can just.
Yeah, I told you, right? So the conditional distributions, given the probability mass function or probability density function, how should we be able to find out? So if you know the density, let's say if I know the density, joint density of f of x, y, and y, how to find out the expectation of x? Do you know how to find it out?
I do remember, but still not
Yes, sir.
coming to mind exactly,
It
sir.
is integrating over the. So if it is a
Yeah,
PDF,
yeah, yeah,
it is
yeah.
the integrating over the range of y, right? Integrating over y, fxy of xy into dx, or sorry, dy, right? Sorry, this is your f of x, the marginal density, right? So let us say this is a PDF, right? Then how to find out its marginal density? Integrating over the y, fxy of y, dy. If I wanted to find fy of y, then it is integrating over the range of x, fxy dx, right?
Dx.
What is the expectation of x? It is integration over the range of y into, or okay, sorry, not y, integration over the range of x into fx of x dx, right? Expectation of y is integration or the range of y, then y into fy of y
Fy by
dy.
dy.
Okay, what will be the variance of x? That is nothing but expectation of x square minus
Square of expression.
x. Variance of y is expectation of y square minus
Expectation of x the whole square, sir.
Square, sir. Square of expectation.
yeah, whole square, right?
Ey
And
square also, sir.
yeah, and how to find out expectation of y square? That is integration over the range of y square into fy of y dy. Expectation of x square is integrating over the range of x, that is x square into fx of x dy, right? So if I plug in all these values, I'll be able to find out its variance. Correct, right?
So in the last it's a dx, sir, not dy.
Dx.
Ex.
Yeah, 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 dx. That is dx. Okay. These all things you should know how to find out. And if it is a PMF, then so if the joint density of the probability mass function is given to me, so if it is the probability mass function, in that case, what is the expectation? First of all, what is fx of x? It is sum over all the y's, right? Sum over all the y's, fxy, y, right? And fy of y is sum over all the x's, or the range of x, this range of y, this range of x, fxy of x comma y. Then what is the expectation of x in this case? It is summation of summation over the range of x, right? And that is x into, right? Oh, so when I say fx of x is what it is? It is a
PMF.
probability. It's probability that x
P
equal
of
to,
x, probably of x.
yeah. So when I say in this case, it is nothing but your probability that the random variable takes the value x. Similarly, expectation of y is summation over the range of y. So the only thing you will have to remember when I wanted to find the marginal density, right? You sum over the y, right? Sum over y, the joint densities, and like that. But when I find out expectation, it is summation over the range of x. So just be, take care of that. And similarly, I can actually find out expectation of x square, and then you can find out the variance. So I may not be, I will not solve those or write down all of this. Okay.
Sir, can we move to week 12?
Huh? Which question you need me to solve here, Devangi? It's solve question number 10. Huh?
So question 10.
Question 10 in this case. Yeah, okay. So this is what fxy of, so this joint density is given to me. So can you tell me what is the joint density here? Fxy is 18x square y square, 18x square y square, and xy is greater than 0, 0, and what is it? X plus y is less than or equal to 1. 0 otherwise. So first of all, let us try to see that whether this is a valid PDF or not, right? Because this joint density is also a probability density function. So we need to see that whether this is a valid PDF or not, right? Before that, I need to see the support. What is the support here? So x and y are greater than 0, right? And what is the other condition? X plus y is less than or equal to 1. That means y is less than or equal to 1 minus x, right? Uh, so if what so when x is equal to 0, y equal to 1, correct? And when y equal to 0, x is equal to 1. So that means uh, the line which will pass through this, right, it will intercept y at 1 and it will intercept x at 1. So the line will be like this, and so this is going to be a line. which is passing through this. So this line is what? This line is y equal to 1 minus x. But I need which area, the support which is inside this, or y will take the so it should be less than or equal to 1 minus x. So everything here will be the support, and your x is greater than 0. So the second and third and fourth quadrant, right? It will not be included in here. I hope you understand this part. So now, how should I check whether this is a valid PDF format? I will take a small strip here, right? And let us call this as a dx, right? And I'll integrate over the range of y. So, and we should see that. And similarly, so first of all, when we need to check, right? So then I'll have to check for the range of x and y, which is 0 to 1, 0 to 1, right? And it's 18 x square y square. Let's say dy dx. Let us say this is y equal to 0 to 1, this is equal to 0 to 1. So then this is what? So integrating over the range of x. First of all, I'll integrate with respect to y, and that is what? 18 x square. So x will be treated as constant. So 18 x square will stay outside. And what is what is the integration of y square? So that will be y cube by 3, and over this domain that is between 0 to 1 and 0 to x, right? So 18 uh, x square 0 to 1, and that is nothing but 1 by 3, right? 1 by 3 dx. So I will be remaining with 0 to 1, 6 x square dx. And what is the integration then? 6 outside, integration of x is x, x square is x cube by 3, and over the range 0 to 1, that is nothing but again
Sir, is it y from 0 to 1 minus x, right?
yes, yeah, sorry, I think it is 1 minus x, right? Yeah, should okay. Should be careful about this. Why it is? Because it was not a square, right? It was this one, right? So either I can do it. So I'm actually doing the integration not like this. Doing the integration. So you can do this also. That is fine. So
You're trying to check the area, right?
yeah, yeah. So
Okay.
so I am taking this horizontal strip. So in this case, x will go from 0 to 1 minus x, or yeah, sorry, that was correct. So this was my support, and if I take a vertical strip, you can take both. Either you can take a vertical strip or so here you see that y equal to 0, and at this point it is y equal to 1 minus x, and x will go from 0 to 1. So all the strips I will take it from 0 to x. Now accordingly we'll have to do it. Sorry, I did a mistake here.
Sir, B equal.
Let me finish this. So it is 0 to 1, and it is 18 x square. This is 1 minus x cube by 3, right? I think yes, that is good. Yes. So this will become integration from 0 to 1. This is 6 x square to 1 minus x cube and dx, and that is 6. If I do directly, right, the integration x cube by 3 minus x raised to 6 by 6 between 0 to 1. Then this will be 6 into 1 by 3 minus 1 by 6. Is that okay? So this is 6 into 1 by 6, that is equal to 1. So this is a valid PDF. Okay, so the next question is, I wanted to find out the conditional expectation of x given y equal to half. So first of all, try to find out what is the distribution of x given y equal to half, right? and that is nothing but what? So if this is a uh, uh, conditional, let's say random variables, how should I write it down? According to the probability, it should be what? Is it not
Joined by marginal.
Joint distribution of fx with x, I don't know, y should be 1 by 2, and then divide by the marginal probability of y 1 by 2.
yeah, so let's say
fxy,
y of x
x,
given y equal to
y,
half,
yes,
right, and fy of half, right?
yes.
Correct. So fy of half will be what? Fy of half is equal to nothing. It's nothing but the integration uh, from 0 to uh, okay. So yeah, so it's like I wanted to find
Oh, 1 minus y.
1 minus x or y. 1
Y,
minus
y,
y.
y.
Correct. It is 1 minus y, the joint density. And what is that? What is that joint density? It is 18 x square y square dx, right? So actually this is x equal to 0 to x equal to 1 minus y. And then in this case, x is y is treated as constant, right? Because let's see, this marginal density
Yes, yes.
should be a function of y, and in that case, let's say 18y square, it is a constant, so I just be integrating over x square, so that is x square by, sorry, x cube by 3, and it is 0 to 1 minus y, and this is going to be 18 y square, is 1 minus y whole cube by 3, and that is nothing but 6. You can think of this as, let's say, y square into 1 minus y cube, right? But I need this fy at half, correct? So I'll just plug in the value of half wherever the y is there. So it is 6 minus half square into half cube, right? So basically it is 6 into half to the power 5, and 2 to the power 5 is 32. 32, yeah. So it is 6 by 32. So this is your denominator. So fy at half is 6 by 32. Okay. Now, what about this fxy of x given y equal to half? So the joint density is actually, what is my joint density? Fxy of
18 x square y square.
18 x square,
X square y square.
and so, and what is this joint density? Fxy of x half, it is 18
18 x square by 4.
half square, right? So it is if it is 4, then it is 9 by 2, right? So it's, can I write like 9 by 2, or you can keep as it is, not an issue. I'll write 18 x square by 4. So this conditional distribution, right? So the distribution of this x given y equal to half is actually is equal to 18 x square by 4 in the numerator, and in the denominator is 6 by 32. So if I do the calculations, it will become 3x square. So it is you can think of, you can understand that this is a distribution of x, right? So it has to be, uh, but it's conditioned on y equal to half. So it is 3x square by 8. Okay. Now I wanted to find the expectation of this x given y equal to half. So the expectation will be over the range of what?
0 to 1.
X, right? It is x equal to 0, x equal to 1, and of which distribution? This conditional distribution, that means this distribution, that is 3, sorry, it is 3x square
So
by,
it will be 24x square, right, sir?
okay, so 6 into 3,
And 4 and 32, right? So 8
4,
will go to the top, right?
yes, 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 correct. So it is, yeah, so it should be 24, yeah, 24x square, correct, correct. This is 24 x square. Yeah. So then 24 x cube by 3 between 0 to 1, and then you will be having 24 by
So you have to multiply the x also, na, sir?
okay, okay, yeah. Yeah, sorry. This is cube, so it is okay. Why we are multiplying x? Because this is the expectation we are doing it, right?
Expectation.
X into this distribution, so it is 24. Then it will be x to the power 4 by 4 and 0 to 1. So I think it is 6. Okay, I think that is the answer. Oh. Okay, I have made some calculation mistakes, so you also be while solving, right? Just cross check your calculations once more. I hope you understand how to solve this problem. Okay.
Yes, sir.
One sir, general query just I have sir, because majority of the topics in week 11 and 12 are from stats 2 sir, basically.
Hmm.
Sir, there's in stats 2 paper there was a list of the formulas which we used to get sir.
Yeah.
But in MLF sir, there is no such formula list which is there. Can we say in the examination, can we just click on the stats 2 and see
Yeah,
the
yeah.
formula?
Definitely, definitely. You can go and check that.
Because first they ask, are you sure to have to give this paper? They then you click yes, then only then you are allowed it to go to then stats to paper, sir.
But I think you can get it. Not an issue with that.
No, we can hover it. We can go and see there. That's not
Yeah,
a
yeah.
problem.
You can go and check that. Not an issue with that.
Thank you, sir. Thank you.
Okay, I think that's it then. Remaining
Sir,
things,
week
right?
12,
Huh? Sorry.
week 12 part.
No, those formulas you will have to remember. I think only few are there, not like many are there, right?
Okay, sir.
Yeah.
No, I meant question solving.
We have solved it right today. No, we have solved the questions, right? Any other particular question you need to solve?
From week 12, sir.
Week 12 is like bivariate and a multivariate normal. You just wanted to find out that is already there. So GMM is not needed. The GMM is Gaussian mixture models. You don't need that one. You don't need the central limit theorem. Just the questions are based on, let's say, Markov inequality, Chebyshev inequality, then the bivariate and the multivariate normal, and the properties of it. I think we have seen some of the questions. I am attaching this PDF also to the calendar. You can just take that from there. So right away I'll just do it. Just let me know whether it is accessible to you or not. We have solved the questions. Okay, we have solved the questions on week 1 and 12. Just go through, and only these topics, whatever I solved, right? I think those topics are important as far as your examination is concerned.
Where can we get the PDF for today class?
Yeah, yeah, now only I'm attaching it. So just
You'll add in the calendar only, right, sir?
yes, yes, I added it. I'm just
Okay.
giving you the access.
Okay.
Yeah, just check your calendar once and let me know whether it is visible for you or not.
Yes, sir, it's visible.
Okay, okay, that's it then. All the best for your exam. Thanks. We'll stop the session today.
Thank you,
So
sir.
Saturday also you will be there, sir?
No, no, I will not be there. Shubham might take the session.
Oh, okay. Okay.
Okay.
Okay.
Yeah.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you, sir.
Thank you very much, sir.
Thank